Thanks for being here. My name's Joe. I'm an Android engineer at a company called Buffer from Brighton in the UK. Today I'm here to talk about ServerDriven UI and how we can use that to scale our UI across different platforms. Just to set some expectations, this talk does contain Kotlin, but it also contains a lot of TypeScript and GraphQL and a couple of other bits and bobs. So when it comes to ServerDriven UI, the server is doing most of the work. So naturally, that's what we're going to need to talk most about here. And I think with this understanding and the ideas that are presented, we'll be able to take that and learn how we can apply it to our projects of our own without worrying too much about the technology that's involved. So let's start with where most of us are today, client-driven UI, which is a great approach, and there's been a lot of success using this, and pretty much all apps I've worked on have used this approach. In this scenario, our API will serve clients with the data it requests, and this data will be in the structure of some form of data objects that represent a response. So for example, if we request a list of articles, we will receive back a list of articles. Or if we request a user, we will get back the object that represents that user. Once we have that data back from the API, the client is responsible for what it should do with it. So we'll get a list of articles back, and then we'll then take that data and massage it into a representable state to display within the UI. So this comes with a couple of, consequences, you could say. We have a repeated layout and presentation logic across platforms. So on our Android, iOS, and web platforms, we have the same presentation logic defined and the same layouts defined. This means we have to define how a screen is laid out. We need to know, should we show certain components? Maybe we want to pay all things or restrict views based on the plan the user is on, or maybe you want to have some form of feature flip. Those need to be independently managed across each of the layouts. And this also means that we need to duplicate any business logic that might be involved around these things also. As well as that, if we make a change in a design or display to a screen, we need to make that change in multiple places. So I have to make that change on each platform. We then have to deploy the change for each platform. And that means the resources that are put into those changes becomes the number of platforms that we have. So if we have 3 platforms, you then need to make that change 3 times. If we have 4 or 5 platforms, and vice versa. And this goes the same again, going back to the business logic, we have to make that change multiple times. And this means that our scope of change is greatly increased because the number of places we are making that change becomes many more.
It's also hard to keep consistency. So we also have we also have to remember that things take different times for different platforms. Some projects will have more complexity, like when it comes to Android, or even maybe a lot simpler in some cases. So something that we add on iOS might be quicker or slower on Android. And even be it lack of a product management or free-flowing teams, it can be quick for us to lose consistency in our products. One team might do one thing, move on to another, whilst another team plays catch up, which can result in some changes or tweaks being missed out in certain places. And any changes that we do make to our UI need to happen for each platform. So let's say we have 2 people on each team working on a new feature. That means we have 6 people working on that same feature across products. And because we are recreating the wheel for each platform for every new feature we're building, or repeating work for each change, that effort then affects the things that come next. So new features and experiments may also see a delay in their development. Now, alongside client-driven UI, we have server-driven UI. And this is something that we don't see often in our field until I started looking into it. That was when I started discovering more things about it and never really had it mentioned to me during my career. And I know some larger companies who are actually using it for either small or large parts of their platform, such as Airbnb, Spotify, and also I think Twitter also use it for part of their apps. So with client-driven UI, we get the raw data which the client controls the presentation for. The difference with server-driven UI is that we remove the responsibility of presentation from the client. So the API will return the presentation to the client, and then it is then the client's responsibility to pass and display that content. So this means that we have a lot of layout logic that will only be defined a single time. So we can define how a screen should be laid out, whether the components should be displayed for that certain user, if they're enabled via a feature flip, and then also handle any business logic on the API side, and then return that presentation to the clients. When we are making changes that apply to the server-driven UI part of our UI, we only need to make this a single time. Because we have essentially some form of design system in place, we can rely on this to handle any UI that we put in place. So that means that we can add new sections to screens, make improvements to existing screens, or add new experiments across platforms without needing to ship any updates. So this gives us more time to focus on building out new features in the app instead of duplicating our effort across the board and reinventing the wheel each time. So if we do make a design change on a screen, we only need to make that change a single time in the API, deploy the change to the API, and then that greatly reduces our scope of change because we're only making that change in a single place. And this also, I hate to use the word resources, but this greatly reduces resources that we're putting into the things that are being built when compared to doing this across multiple platforms. With specific parts of our app being controlled from a centralized location, we will now start to see some benefits in the form of consistency. So as a change is only being made once, a feature implemented once, we can be sure that all platforms offer the same UI and functionality across the different platform offerings. So we can see these two approaches are essentially quite different. And it's not only is it a mindset shift, but it's a complete implementation shift. Like server-driven UI isn't something you can just whack into an app that's currently using client-driven UI. It requires a bit of change. So while we're likely using client-driven UI at the moment and being used to that, I thought it best to run through a real-world example of server-driven UI. So I want to jump straight into this example, and this is a side project of mine called Compose Academy. Compose Academy doesn't have the most complex UI, so bear that in mind. Server-driven UI doesn't work for everything, but for this, it works pretty well. So on the site, you can essentially browse a collection of categories and subcategories, along with then viewing an article for that selected item. So all of the UI here, apart from the menu bar at the top, is completely controlled by the server. I'm also in the middle of working on Android and iOS apps, which are almost done, and they behave in pretty much the same way. With this being a side project, I sat down before I started building this and wondered, what could I do differently? I think side projects are a great place to, think outside the box, try new things, and do stuff that you're not, different from the way you usually do it. And server-driven UI seemed like an obvious one to go for, as you do. So when it came to Compose Academy, I knew that I wanted to build various clients, with each of these clients displaying a very similar kind of UI. I decided to mix this in with Kotlin multi-platform for the mobile side of things, and I thought I would end up with a pretty lean client setup. So I'd be sharing my UI logic because that would be done on the server, and then also sharing my business logic through Kotlin multi-platform. And because each client would have a very similar UI, this would be a pretty seamless experience. So before we dive into the client side of things, I want to first focus on the API. And whilst this isn't strictly Kotlin, as I mentioned before, it is the main focus for server-driven UI, and it's what will be driving the contents of our clients and where most of the work will be involved. So if we hop back over to the image I initially shared at the start of this talk, we can see the kind of response that we'd be providing to our client. In this response, we describe the UI to the client rather than just the data that was requested. So in this presentation array in the middle of the screen there, we can see different objects that essentially represent different UI components. And looking at the UI for the client of Compose Academy, which in this case is the website, this is kind of what we have at a high level. So from the left-hand side, we start with the categories. This is a list of cards that shows the top-level categories for Jetpack Compose. So these are things such as layout, material, and tests. We can see this is made up of an app bar followed by a supporting list, and then that list contains nested UI in the form of detail cards. For the subjects and topics, the UI is exactly the same. We have an app bar with a list of content. And then finally, we get to the article screen. This is a vertical list of content that can display a variety of content items. So personally, I feel like this is where server-driven UI really shines. We essentially support blocks of different content types, and the UI will render whatever we chuck at it. So here we can start to see how different UI components are used to make up the different screens of the app. And we can also see that everything is very structured, something that a lot of applications have in common. Most apps will show us a collection of content in some form of vertical or horizontal structure. And with that said, I want to highlight one of the key things that I've noticed when working with ServerDriven UI, and that is you need a design system. With ServerDriven UI, you're going to essentially have a pool of predefined UI components ready for use. So when the presentation of a screen is received, this pool of UI components can be used. This allows you to have a one-to-one matching when UI is returned from the API and then generated on the client side. These UI components from your design system essentially become building blocks, which can be put together to build up your UI. So with the design system, essentially, when you get the API response back, you essentially have some form of factory that's like, hey, we need to show a vertical list, which shows some text, followed by these detail cards. And the factory will essentially take that API response and use it to map to UI components which are defined in your design system. So with that in mind, we actually need to, build the design system. And when we think of a design system, we essentially think of, the visuals and something that we might design, I don't know, maybe in Sketch or Figma or whatever you're using. But because our server is driving the UI, that's where, that's going to essentially be the contract for our clients. So when we define a design system in client-driven UI, this will live in our clients. So if I've got a design system, my Android app, my iOS app, essentially we will define that within the app itself. So within server-driven UI, our API essentially needs to know about our design system. This is because it needs to know what UI components it can provide, along with what those components are made up of. So at first, this sounds a bit funny, but with the use of a strongly typed language, such as TypeScript, these UI components essentially become types. And we essentially define a contract for what UI components are supported, and then that needs to be implemented by our client. So for example's sake, here we define a couple of UI components that are supported in our design system. So we have this text component along with the detail card component. So within each of these types, there are properties which represent what that component is made up of. So the component type here you see is just some enum representation that GraphQL needs on the API side as identifier. But when it comes to handling this on the API side, it would essentially build objects that would represent what these components look like, and then they can be returned to the clients. And then on our server, I'm using Apollo, the Apollo GraphQL library. So that will essentially take my responses in my resolver classes and then map it directly to these types. So the client will receive a strongly typed UI component back as the response. So there's no hard coding or checking of specific things on the client. We will literally get a typed response back, which can be mapped directly to our UI component. So say if I want to return a text component from the API, I will return an object like this, satisfying the needs of what a text component requires, which is just a simple content property. And similarly, if we were returning a vertical scroller, again, we will return an object that represents what that is made up of, along with the children that then make up that content. So our API will essentially build the components that are required and then return those objects for them to be mapped to strongly typed elements. So now that we have these UI components defined and we have our API design system in place, we need to be able to query them from the client. So let's use the categories screen as an example. It has the same UI as two of our other screens and represents a simple kind of minimal layout that needs to be built by the server. So for the category screen, we will define a categories query that will return us this type of presentation. So we can see above here that presentation represents an array of components. These are the UI components that we looked at on the last slide. So when we return our presentation to the client, we're essentially just going to return an array of UI components, and then that array can be used to map to a visual representation on the screen. We're using this presentation type here just so that we can define different queries and they can each just return that presentation response. So here, we can see here that, we're returning the list of components that are previously defined in our design system. So as we add more components here, we can add different types that we can support for our design system, and those will be returned as the presentation of our response. So with those queries in place, we now have something that our clients can use to retrieve the presentation for a specified screen. So before we go ahead and write the actual query that will be used by clients, we need to take a look at what will make up that query. And for this, we will use something that GraphQL provides called fragments, not to be confused with Android fragments. Fragments are essentially reusable sections of a query. So when working with ServerDriven UI, it's likely we're going to be querying for the same types of components in different places because of the fact we're working with a design system. So we can see when I had the screens up before, we had the categories, the subcategories, and then we had the article screen. All of those show all of the same components, but just in different ways. So having these reusable formats for queries allows us to share those across the different queries we're performing. So fragments are also a nice way to retrieve optional content. You can basically chuck your query a collection of fragments and it will just populate the ones that come back. If you're new to GraphQL, you're thinking of checking it out, I'd highly recommend looking at fragments when you come to performing these kind of queries. So we start here by defining how we're going to query for the detail card component. And then we're going to query for the scroller component along with its nested children, which in this case is the detail card, followed by collating the different components we want to query for inside of the general component fragment. So this component fragment can then be used across our different queries, and any of the available types from the API can be returned to represent our UI. So whenever we perform a query, we can just query for this components, and anything inside of that will be queried for and returned if it's available. So when we write a query, we use the components. And then because doing the same thing across the different screens, we're just querying for a presentation, we can reuse that same approach when querying across different screens. And if you've got different components, maybe if you want to split things out, you can have kind of different component fragments to represent different states. But if there's a lot of crossover and similarity between screens, just querying for all components is not too harmful in doing that. So let's take a quick look at this query, just in case you're not too familiar with GraphQL. It's helpful to understand how these work. So we start here by defining a new query and giving it a name, and this can be whatever you want. I'm calling this categories query because I'm querying for categories. Next, we state the operation that we're going to be performing. On our API, we had defined a query called categories, so that's the one that we're going to be using here. And inside of this categories query, we then define the data that we want to retrieve. We don't have much choice here as our presentation type only returns a collection of children. So we define that we want to receive children for the categories. However, where the magic happens is where we utilize the components fragment that we previously defined. Here, we are essentially querying for all possible types of UI components that are defined in our API design system, which allows our UI to be queried and returned in its entirety. And this means that if the API changes, so what is returned at some point, maybe we modify the server response, we add or remove components, our query will already have those changes reflected in the client because we're querying for all possible components. So if we update any response on the API, we can be sure that our client will always have those changes in place without needing to ship any updates. So now at this point, we have our API set up to return a requested presentation. We need to actually do something with that from the client side. So for this, we'll be using Android as an example. And the process is pretty much very similar to iOS and web and is actually quite minimal once you've done the kind of response passing. So in terms of GraphQL and Android, we'll be using Apollo GraphQL for Android. This is a client-side library, and it offers a lot of functionality, specifically code generation. So here we'll just be giving a kind of a little bit of an overview of it, but it's definitely worth checking out if you're exploring GraphQL in projects of your own. So when it comes to the client side of things, there are still a couple of steps that are involved. So we need to set up the Apollo client, which involves copying the schema into our project. We need to define the queries that will be used for retrieving the presentation data from the API. We need to perform these queries to retrieve that presentation data. And finally, we need to pass the presentation data so we can render the UI components on screen. So the first thing we're going to do here, this is a required part of the Apollo client library setup, is adding a copy of the API schema into our project. So Apollo Android needs this so that it can generate the strongly typed project code, meaning that we'll have access to the UI components and fragments that we previously talked about in a strongly typed fashion. And this is because the schema for the API, which essentially represents the structure of the API, will contain all of the details about the design system and all the queries that are available. So that's in a JSON format. So once that's added to the project, Apollo Client Library will use that to generate the strongly typed code. So you'll have your API design system available in that strongly typed fashion. And you have to also do the same thing with any queries or fragments that you want to use inside GraphQL extension files. So these are the query that we previously saw for the categories. You essentially add these into your project in these GraphQL files, and then Apollo will also generate strongly typed code for these. So again, the query we're focused on here is the one we looked at in the previous section, one that can be used to retrieve the presentation for the category screen. And this is based on querying the collection of UI components that make up that presentation. So with this defined inside of those files, when we build our Apollo Android, when we build our project, Apollo Android will generate a query class for us that we can use to execute. So once generated, this class can be used when we're executing an operation using the Apollo Client Library. So I won't go into the details of the Apollo Client Library here, but it's quite minimal to set up an Apollo Client Library instance. We just need to create a new instance within our file, and we can use it to execute queries and mutations against, which are essentially get operations and post operations. So when you perform a query, you provide the generated class, and you can execute that. For this block of code overall, we're using the client to execute this query and then storing the result in a variable, catching an error should something error during the request flow. But if things go as planned, this response is going to consist of a model representing the result of the query operation. Now, because we're using a complex query consisting of many fragments, we need to take a look at what this looks like. So we start here at the root of the response. The data of the response represents the entire pass response of the GraphQL operation. This would be null if there was an error, but we're skipping that here for simplicity. So our query definition itself makes up the parent of the response model. This model is going to contain several high-level properties, such as errors and datas, and the data will represent the result of what we've queried for. So inside of that result will be the categories. So inside of our query, we can see we query against the categories from our API, which means our data model is going to contain a model that represents the structure of our categories request. Now, because we performed a query on categories, Apollo has generated a response model based on this. So we defined our query and the fragments that are to be queried for. So Apollo generated a response model for that, which means we can access all of this in a nice typed fashion. So if we remember that query that we defined in our API, the presentation type that returns a list of children, Apollo generated a Kotlin type for this, so we can access those children in that same format. So with that in mind, we can access the children from the categories response. When we query for the categories, we query for the children of these categories. These are represented as a property inside of the categories data of the response model. If we remember from when we broke down this query previously, we were using fragments. This is what the body of these children are going to represent. So at this point, with this children property, we have a list of fragment models. We saw this in the generated categories model previously, but again, Apollo has generated this child class for us based on that query we defined earlier. And inside of this child, we can see a fragments property, which contains all of the fragments that we queried for. Now, fragments aren't too helpful on their own, and we have to do a bit of digging in to get out the things that we need. So now that we're at the access point for the children in our GraphQL response, we want to take this collection of children and convert them to a list of components. This remote call is made from a data repository, and that repository does not care about the response data, categories, or children. It just wants the collection of UI components so that it can pass those to composable functions. And for that reason, we take the children here and use the Kotlin map operation to create a collection from each child's fragment component. To access these and make them usable to our app, we're going to want to access the different parts of these fragments. So here, our children could represent a collection of different UI components, with each containing fragments of our own. What we would do here is essentially go through each of these fragments, retrieve the UI components from each, and map that to a list so that it could be handled within our app. So we can see here again, we've got these typed fragments that Apollo has generated for us. So we basically fetch these within that map operation to have a list of fragment UI components. With that in place, we have that query available, and we've gone through that response data and fetched every single UI component that is available from that. It does feel a little bit complex, but with the way the query operates and the way the components are structured, that needs to be done to be able to get the things that we need out of it. So in our repository, if things go as planned, we're going to get a response back from the Apollo client that contains all of the required data for our presentation. Let me skip that. So with our UI components in place, what we need to do now is map these to a model that is suitable for our app. So this Apollo client library is Kotlin multi-platform friendly. It does support Kotlin multi-platform, so that is inside of its own module. But the thing that always worries me about these third-party client libraries is when they generate models and you end up passing those models around your app, and your app becomes sort of tightly coupled to that third-party client library. If things change or you decide to use something else, you have a lot of scope of change because you're coupled to that implementation. So what we're going to do here is what I do in Compose Academy is map them to an internal model representation which is used by my app. So yeah, and the reason for doing that is just each of the models that's generated by Apollo contains a lot of code, a lot of things the client doesn't actually care about. So outside of being coupled, there's a lot of things inside those classes that we don't need to know about. So for this reason, I map to essentially my own representation of these. So instead of being those bloated files that are coupled to Apollo, they'll just be simple data classes representing the UI components that can be used. So each containing the different properties that make up our UI components. So what we'll do when we get the response back from Apollo is map each of those GraphQL models to our internal model, which can then be used within our application independently of the Apollo dependency. So each of these internal models will just represent a different UI component that is available from our design system. So each will extend from a generic component class, and we can see here an example of the vertical scroller that contains a list of components inside of it. And then one of those components in this list could also be a detail card, which represents a model that comes back from our API. So these mappers aren't actually doing anything magical. They're simply just looping through each of our fragments and their corresponding components, and then converting each to an internal model. So we can see here that if there is a vertical scroller fragment inside of the component list, then we go ahead and map that to an internal representation. And similarly, we do the same thing with all the other components. We're just looping through the children and then mapping them to their internal representations. And at the end of that, we end up with a collection of models that represent what we need to show in our UI. But how do we do that? So at this point, we know we want to take these internal models and generate composables for them. And this is a really nice flow, as we can check the type of the internal model that has been passed to the function and then generate the corresponding composable for it. So if we had an internal model that represents a title, we can generate the corresponding composable for it using the title text composable. This has all of the properties that match our design system that is specific to our application. So here we can just see we've got a when check, and then when that component matches a specific class type, we return the composable function that is specific to that. So here we have the title text, and we have the same thing also for an item list. So I've got a list of items here. We pass in our vertical scroller, we create a lazy column, and then we build the items for that lazy column based on the contents of that vertical scroller. And again, this is just taking an internal model, checking what type it is, and then using a composable function based on that type. And at the end of that, we've got a system that allows us to pass internal models and build composable and use composable functions from it. And when it comes to composing our entire UI based on these internal models, we can simply loop through each one and create a composable that is to be composed inside of our UI. And whilst these are just two small examples of those UI components and composables that are mapped to it, we can start to see how this can map out. So looking back at the original diagram I displayed for the design system that would be represented by our API schema, we need to provide composables that represents each element from here. So with this in place, we are able to handle the requirements and the contract that the API provides and map that to a screen presentation. And whilst I'm using composables here, the same thing is for Swift UI, looks very similar. And also my React web app looks very similar to this. We've got mappers that take the GraphQL models, map them to their declarative UI pairs, and then just display that list of composables or declarative UI components on screen. And that's all. The screens are just essentially displaying those composables, and they don't have too much else to them. So just a couple of closing thoughts. Server-driven UI is a complete change of approach. It's very different from client-driven UI, and it needs a bit of a different thinking mindset. Like you're essentially returning a presentation response rather than just returning a data format. We need to start thinking of our presentation as a list of components rather than something we define in a layouts file. Need a design system. Without a design system, things could get pretty difficult and pretty hard to maintain. Having a design system allows you to avoid having sort of checks and manual tweaks in place for certain conditions. There was a few things that I tried adding outside of a design system, and it was a bit of a pain. So that's probably a bit of a con of this approach. Like, it can feel very constrained at times, but if you have a strict design system, then it would probably work great. And reusable components for a design system, essentially allow you to achieve this. So at first, it was a lot of work. It was actually quite slow to get started with the project because, we're defining support for all components that are available in our app, and we're sort of building a server that handles all that. When we usually build layouts, we build them when they're needed. But now we're trying to think ahead and set up everything for when it's needed in the future. It can feel like more work up front, but in the long run, we could spend less time in places where it would have previously been needed. I've added several new features to Compose Academy, and I added a whole blog feature, and it honestly did not take me that long at all because I reused these queries and reused the framework I had in place to add those things there. And it was, very, very easy to do so. So a couple of pointers like around server-driven UI, which could be seen as cons, is I think it's important to know when it works best. Originally, when I first built Compose Academy, so I mentioned at the beginning that the toolbar wasn't built with server-driven UI, that was being done on the client. If you're handling things such as navigation or like top app bars or things that really, trigger actions in the app, like a specific places, that's probably best done in a native, not native fashion, just on the client. If the server's trying to do too much and you're overcomplicating it, we'll hit a wall. And I struggled quite a bit. Originally, when I started it, I went all in and tried to do everything on the server just to try and see what I could push. Originally I was doing all trying to do the navigation and the app bar, and didn't really work. So I think know what will be maintainable, know what you'll be able to work with in future, and if something feels like maybe it's tricky or it's too hard, maybe it's not worth having the server drive that. I think that's maybe important to remember. And importantly, no silver bullet. Server-driven UI isn't for every project. It will not solve all your app problems. It will not magically fix all your inconsistency issues that you might be facing. And I don't think it's a replacement for client-driven UI. I think it's something that can work alongside client-driven UI. Like, a lot of companies use it for A/B testing, and also for screens that maybe are dependent on specific user information. Like, I know companies like Deliveroo do that with their menu, with their store screens. They use server-driven UI. But I think with paired with client-driven UI and using the right places, I think it can be a powerful tool. And most importantly, is keep it simple. If you are thinking about playing with this in a side project, or maybe pitching it to your company, if you think it might be beneficial, I think maybe start thinking about what is the smallest part of the app, or the least configurable part of the app that we can drive using the server, and start small, start simple.